Okay, where I only know my volume. So I'm going to use A to figure out the concentration of B. Okay, so use A to determine the concentration of B. Okay, so when it's asking for molarity, that's just moles per liter. Okay, that's what molarity is. So whenever you see the question has a capital M like that, it's just moles per liter. Okay, so this is what I'm going to do. Step one, I'm going to determine how many moles of NaOH I've used. Okay, so moles NaOH. Okay, I have 32.8 milliliters. So 32.8 milliliters is the same as cubic centimeters. So now I do 1, 2, 3. So that is equal to 0.0328 liters. Okay, so that's how many liters of NaOH I've used. So now 0.0328. Okay, I'm going to take the volume of NaOH that I've used and I'm going to multiply it by the concentration. So that is 0.162 moles per liter. Okay, and I have used zero point zero three times 0.03136 moles. Okay, so that's how many moles of NaOH I've used. Well, how many moles of H2SO4 does that correspond to, right? So I need to link these two together. I need to link these two separate chemical entities together. Okay, so how can I link them together? What do I need to figure out? The hard question. If you're not there yet, it's okay, but some of you might have an idea. Okay, I'm going to write an equation. Okay, so equation. So NaOH plus H2SO4 gives me NaSO4, so that would be Na2SO4 plus HOH.
It can't be that simple. Well, the pressure has to be in kilograms.
So I just balance this. So 2Na, 2Na, if 2 OH, I need to put a 2 here, 2 hydrogen, 1 SO4, 1 SO4. So it's balanced. Okay. So now, thanks to my equation, I'm going to figure out moles of H2SO4. Because they're going to start calling you guys down. So people in class, I have 0.0053136 moles NaOH times. I want to cancel NaOH. I want to finish with H2SO4. So when I link them, that's 2 moles NaOH for every 1 mole H2SO4. And I get 0.02658 moles of H2SO4. Okay, so for my H2SO4, I have this many moles. in this many milliliters. Okay, so I need to translate that. So now we're going to find the concentration. H2SO. Okay, so my concentration of H2SO4, I have 25.0 mils, 25 mils. Okay, that's 1, 2, 3 equals 0.025 liters, 0.025. Okay, just gonna write it decimeters cubed. And now I just take my mole per liter because that is concentration. So 0.0026568 over 0.025 equals 0.106272 mole TM3. Okay, let me check my sig figs. So 3 sig figs, 3 sig figs, 3 sig figs. So I need to make my final answer be 3 sig figs. So that is 0.106 moles DM3. Okay, so that is the concentration. That's the concentration of the H2SO4. Okay, so that's just a titration question to warm us up. So the next questions that we're going to be doing, something called a back titration. So I do think I've seen a question on it in your question packages, which means that, you know, IB in the recent past has used the concept of back titration on an exam. So might be better to be prepared for that than not. I'm pretty sure I've seen a question on back titration. So I take you through a bunch of examples that, I don't know, if you pay attention, you shouldn't find them tedious. But if you're kind of, what the heck? Oh, did I miss a question? Okay. So we have one more titration question to do, and then we'll move on to back titration. Let me just get my filled in sheet. Okay, doke. Okay, so we're used to acids and bases neutralizing each other, right? But you can also have an acid be neutralized by carbonate. Okay, so here you have the reaction. Okay, so 2 moles of sodium hydrogen carbonate, so baking soda, neutralizes sulfuric acid to give you sodium sulfate plus water plus carbon dioxide. Okay, so you've got a carbonate neutralization. So let's take a look at our question. So 25 cubic centimeters of 0.1 mole per liter sodium hydrogen carbonate. Look at that. You have something where you know the concentration and volume. Okay, so this thing where you know the concentration and volume, it was titrated with dilute sulfuric acid 15.20 cubic centimeters of the acid were needed to neutralize the solution. Calculate the concentration of the acid. Okay, so what we need to do, we need to figure out moles of the one where you know the concentration and volume. Use that to figure out moles of the one where you don't know the concentration, and then go from there. So moles, NaHCO. So now I have 25 cubic centimeters. I'm going to make that liters, 2, 3, 0.0500. Okay, so to find moles, I do 0.02500 dm3 times. So for my sodium hydrogen carbonate, I have, it's 0.100 mole per liter. So my liters cancel. And for my sodium hydrogen carbonate, I have 0.0025 moles. Okay, so to neutralize my sulfuric acid, I needed 0.0025 moles of NaHCO3. So now let's see how much sulfuric acid that corresponds to, because we need to figure out moles of sulfuric acid. Okay, so I have 0.0025 moles of NaHCO3. So how many moles of H2SO4 does that correspond to? Okay, so 2 mole NaHCO3 to 1 mole H2SO4. Equals 0.00125 H2. Okay, so that's how many moles of H2SO4 has been neutralized. Okay, so now I just need to find my concentration. Well, I have a volume, so 15.20 cubic centimeters. So here we have moles NaHCO3. Here we have moles H2SO4. So now we're going to figure out concentration H2SO4. Okay. So concentration is mole per liter. So for my volume, I have 15.20 cubic centimeters. 1, 2, 3, 0.01520 dm3. So 0.00125 mole over 0.01523. That is 0.0822. Okay. Wait, is that the right number of sig figs? 4 sig figs, 3 sig figs, 4 sig figs. So I need to do it to 3. Yep, so that's right. Okay, so that's the concentration of my sulfuric acid. Okay, so now you have examples of titrations, acids and bases and carbonates and acids. Okay. So we are going to move on to the topic of back titration. Again, I've seen questions on it. It's also something I can see you doing your IA on. Like, this technique is, it looks like it's very conducive to an IA, to an internal assessment. Okay, so what is this thing called a back titration? Okay, this is used when the unknown compound cannot be dissolved in water. Okay. So the compound can be reacted with an acid using a neutralization reaction, and then the remaining acid is then titrated. Okay, so that's a back titration. It's kind of like, it's sort of the way it works is you find out how much of something you've used by how much you have left over. That is my carbonate. Okay, my carbonate. So this is, I've got XCO3 here, and I'm arbitrarily putting 2 of these formula units. Okay, just to show that at the bottom of my beaker, I have some carbonate. Okay, so do I know how much carbonate I have? Yes, I do. I put in 138.04 grams. Okay, so that's how much carbonate. So I've got 138.04 grams of this white powder on the bottom of my beaker. So now I want to do some reactions with these, but you know, carbonates, they're not very soluble. So like calcium carbonate, if you ever put like if chalk, if you ever powder chalk, I don't know why you would ever do this, but if you take chalk and you powder it, it will not dissolve in water. It'll go in the water will look like milk for a bit, and then the chalk will settle out. It's not soluble. It's just a property of carbonate, so it can't dissolve in water. So I am going to dissolve it in acid, and I'm going to pour in a lot of acid. Okay, I'm going to pour in so much acid. So I have actually poured in 1 liter of 3 molar H2SO4. That is how much acid I have poured in. Okay, so 1 liter, let's say it's a really big beaker. So I have 1 liter of 3 molar H2SO4. Okay, so I've got H2SO4, right? It's aqueous. So it's ions. So I have got hydrogen ions. This should be SO4. Okay, and some H, and that should be a 2 minus there. H plus, SO4. Okay, so my acid reacts with my carbonate. Okay, so here my acid reacts with my carbonate. Here my acid reacts with my carbonate. Okay, and I have some acid left over. So I have this much acid left over. Okay. So now I want to figure out how much acid I have left over. And to do that, I'm going to pour in some base. Okay, I'm going to pour in enough base to just react with my leftover acid. Okay, it means that I'm going to have to titrate my leftover acid. So I'm going to have to drip in base, and then as soon as an indicator changes color, I know it's neutral, my acid's been neutralized, so I stop pouring in base. So I pour in some base, okay, and my base, the concentration of my base is 2 molar sodium hydroxide. And I've poured in 1 liter of it. Okay, so I've poured in 1 liter of 2 molar sodium hydroxide, and that neutralizes my acid. So my sodium hydroxide neutralizes my acid. Okay. So after I've poured in 1 liter of sodium hydroxide, my indicator changes color, tells me it's neutral. So this is how, and don't forget what you're calculating, right? You're calculating the identity of the metal carbonate. So what you want to calculate is the identity of this metal carbonate here. Okay, but we're going to work top down. So we are going to figure out how many moles of base were used. That's going to give us how many moles of acid was left over. From your leftover moles of acid, you could figure out how much acid was used. And then from the amount of acid used, you can figure out the amount of your carbonate. So let's just do the calculations, because what I probably just described to you doesn't make a lot of sense. Okay, so how much base was used? Well, I used 1 liter of 2 molar sodium hydroxide. So 1 liter times 2 mole per liter. So I have used 2 mole NaOH. Okay. So how much acid did the base react with? Well, if I have 2 moles of sodium hydroxide, let's write out an equation, right? So I have NaOH plus H2SO4 gives me Na2SO4 plus HOH. Let's balance it. So this, put a 2 there and put a 2 here. Okay, so it's a 1-to-2 ratio. So every time I have 2 moles of sodium hydroxide, I get 1 mole of sulfuric acid. Okay, so it's a 2-to-1 ratio. So 2 NaOH to 1 H2SO4. Okay, so therefore, 1 mole of H2SO4 was left over. Okay, because that's the amount of H2SO4 that my base reacted with. Okay, so how much acid reacted with the carbonate? So, oh, somebody is commenting. Hold on, let me just see the chat. Can I repeat the ratio part? Do you want me to repeat the ratio part? Yeah, I can repeat the ratio part. Okay. Maybe I will go down here. And we can make this in blue. Okay, so this part. So I have 2 moles NaOH. Okay. How many moles of H2SO4? So I want to know how many moles of H2SO4 2 moles of sodium hydroxide corresponds to. So whenever you have one quantity and you want to figure out another quantity, you have to link the 2 quantities with an equation. Okay, so this is my equation up here. Let's just copy it. Okay, there's my equation. Okay, so I have 2 mole NaOH times. For every 1 mole NaOH, sorry, it's not paying attention. Okay, so for every 2 moles of NaOH, I have 1 mole H2SO4. Okay. So 2 times 1/2 is 1 mole H2SO4. Okay. So your sodium hydroxide, based on the amount of sodium hydroxide you have, the amount of sulfuric acid that corresponds to is 1 mole H2SO4. Is that better? We just did a mole ratio. Okay. Okay, good. Good. I'm glad you understand. I'm glad you asked. All right. So how much acid reacted with the carbonate? Okay. Okay. So let me go back to the picture. These are long questions. Okay. So what I've just figured out is this. Like, this is what I've just figured out. Okay. What I have to figure out now is this. What reacted with my carbonate. Okay, so what I'm actually going to do is I'm going to, like, this base is too small, so I'm going to be sneaky and shrink this. And then I'm just going to write this one. Okay, so let's write it over here. Okay, so total amount of acid. Okay, so my total amount of acid, all my acid, all the acid that I've poured in here. Well, I poured in 1 liter of 3 molar H2SO4. So that's 1 liter of 3 molar. Okay, and molar just means mole per liter. So that's 3 moles of acid. So that is how much acid I've poured in total. So the amount of acid I've used, okay, I calculated that in my previous question. So I used 1 mole of H2SO4. Sorry, not going to write the reduce. I'm going to put left. This is how much acid I've left over. So to determine the amount of acid used, I just subtract them. So 3 mole total minus 1 mole of acid left over is equal to 2 mole acid used. Okay, so I've used 2 moles of acid. So how much acid reacted with the carbonate? 2 mole H2SO4. Okay, so how much, so this part's gonna, okay, this part I'm just wondering how to explain to you. It's probably the hardest part of this question. Okay, how much carbonate was there? And I really should give myself more space to write in. This to the side. Okay. So how much carbonate was there? So let's just write that. So 2 mole H2SO4 corresponds to mole of my CO3. Right? So when I have my acid reacting with my carbonate, so I have my acid reacting with my carbonate is a CO3 plus. So this CO3 plus, it needs 2 H pluses to react with it. Okay. Reacts with 2 H plus. So 1 H2SO4 gives me 2 H plus. Okay. 1 H2SO4 gives me 2 H plus, and the 2 H plus reacts with 1 carbonate. 2 H plus reacts with 1 CO3. Okay, so I have 2 moles of H2SO4. My first mole of H2SO4 produced 2 hydrogen ions. That reacted with 1 mole of CO3 2 plus. My second mole of sulfuric acid of H2SO4 produced another 2H plus, and that reacted with another carbonate. Okay. So in total, I have 2 moles of CO3 2 plus. Okay, so I have 2 moles of CO3 2 plus. You really have to, like for chemistry, you have to get really good at thinking in terms of ratios. So for XCO3, okay, so if I have 2CO3 2 plus, therefore I have 2XCO3. So I have 2 moles of XCO3. Okay. So now we have this gram, right? We have 138.04 grams. So 2 moles of XCO3 weighs 138.04 grams. So if I took 138.04, divided it by 2 moles, grams, 2 mole, okay, that is 69.02 grams per mole. So my molar mass of carbonate, like the molar mass of this XCO3, is 69.02 grams per mole. Okay, so mass CO3 minus equals 60.01 grams. So to figure out the mass of X, okay, 69.02 minus 60.01 equals 9.02 gram per mole. Okay, so X has a mass of 9.02 grams per mole. So what element has a molar mass of 9.02 grams per mole? That is beryllium. Okay, so my carbonate, oh my gosh, this is looking at such a mess. My carbonate is BeCO3. It's beryllium carbonate. Okay. So something you want to go over step by step. So we've got 2 huge, long questions to do. And then after that, we're done. We're done solutions. Okay. Okay. I'm gonna pour myself some more coffee while you go ahead and digest that and copy that down. I know it's evil.
Yes, was there a test for this unit?
There is, yes, it's next week. Monday will be, no. So, your multiple choice, I'm gonna make it, when do we have study hall for this class? On Tuesday? So your multiple choice and I'll give you more information on it as the idea, like what I'm gonna do for your, I'm not calling it a test, I'm calling it an evaluation. So your multiple choice, I'm gonna make it a Google form and you're gonna do it like during class. So I'm not gonna make it very long. It's only gonna be like 10 questions. So you're gonna do that part during class. And then I think the actual like evaluation itself, I have to sort of get away from doing this. But just because it is something you'll be submitting online and the slew of problems that can arise from that, I'm probably gonna put it up over the weekend and make it due Monday.
Okay, thank you.
Which I'll probably get in trouble for. But again, if your internet decides to crash and you have to go and call your internet provider and then it turns into that, I don't know. I'm not comfortable. I'm not comfortable giving you like an extra hour to scan everything in because I know there might be complications. So it is independent though. I will tell you this right now. And since I am procrastinating from finishing the rest of this note, I'll tell you what happened to a group of IB kids. I think it was last year. So here, you know, if I catch kids copying off of each other, like I'll take marks off, right? For me to give the whole thing a 0, I don't usually do that. I will cut marks off. I will say, well, you copied this part, so I can't give you credit for this part, so we'll take marks off. What happened with IB was the extended essay, 2 kids had the same, like it was like a few sentences. It wasn't the whole essay, it wasn't even a whole paragraph, it was a few sentences that were the same. And IB noticed it, and they pulled their entire diploma. So it's not like they got a 0 on the extended essay. It's not like they got a, you know, they failed one of the credits for IB. Their whole diploma was gone. So IB is ridiculously strict with academic honesty, ridiculously. And like if it came down to it, where cheating was an issue, and you know I had to declare it that my IB students are cheating, I don't know if they would have me give you harsher penalties as well. So please do your work independently. You're given many hours to do it. There should be no reason for you to collaborate. Don't even collaborate on it. Do it yourself. Okay? Don't even say, how do I do this question to your friends? Because you'd be surprised how similar your answers can end up being. Okay. So another monster question. If you're like me, you enjoy questions like this. I think most of you are not like that though. It's okay, we've only got 2 more to go. Okay, so 0.5214 grams of impure calcium hydroxide was dissolved in 50. I hate it when they do this. Just give me liters. Please give me liters so I don't have to go and now draw this and move my decimal places 1, 2, 3, because I can't in my imagination see where that decimal ends up. So I actually need to do this. Okay. So I have 50 cubic centimeters of 0.25 mole per liter hydrochloric acid. When the reaction was complete, 33.64 OIB. Who writes these questions? Okay, 33.64 cubic centimeters of 0.1108 mole per liter. Aqueous sodium hydroxide was required to just neutralize the excess acid. Ugh, looks like a back titration. Assuming that the impurities do not react, what percentage of the sample was calcium hydroxide? Okay, what the heck is this question even talking about? Very complicated thing. Okay, so we're gonna draw what's going on here. Okay, so I have calcium hydroxide. So calcium hydroxide is CaOH2. Okay, so I've got calcium hydroxide, and I pour in a lot of acid. So the acid that I'm pouring in is hydrochloric, so it's HCl. Okay, so it's HCl. So in my, and again, this is arbitrary. So H plus, Cl minus, H plus, Cl minus. Okay, so that's what my acid looks like when I pour it in. So my acid reacts with my calcium hydroxide. So this 2OH, okay, so OH is like that, right? And I've got 2 of them. So I'm going to need 2 H pluses to neutralize my OH2. Okay, so that's kind of how the ratio works out. Anyway, I've poured in so much acid that all of my calcium hydroxide has reacted, and I have some acid left over. So now to figure out how much acid I have left over, I'm going to pour in my sodium hydroxide. Okay, so my sodium hydroxide neutralizes my acid. Indicator changes color, telling me to stop. And now I've got a bunch of numbers that I can use in my calculations. Okay, so let's sort of attach some numbers to this. So here, this was 0.5214 grams. I have poured in 0.1. Nope. I've poured in 0.050 liters of 0.25 molar hydrochloric acid. Okay, some of that acid's left over, and then I need 3 point. Again, I need this in liters. 0.03364 liters of 0.1108 mole sodium hydroxide. Okay, so it's kind of attaching numbers to this. So what I'm going to do, I'm going to take my sodium hydroxide, figure out how many moles of sodium hydroxide I have. From that, I'm going to figure out how many moles of HCl were left over. From that, I'm going to figure out how many moles of HCl reacted with the calcium hydroxide. And from that, I'm going to figure out my moles of calcium hydroxide. So let's do let's do the sodium hydroxide part. I think is pretty easy, right? So I have some leftover HCl. Oh my gosh, we're going to finish this in time. Okay, so I have some leftover HCl. Okay, so how much is left over? Well, how many moles of sodium hydroxide was necessary to react with that? So I have 0.0, so this is moles, NaOH. So I have 0.03364 liters times 0.118 mole per liter equals 3.727 times 10 minus 3 moles of sodium hydroxide. Okay, so that's how many moles of sodium hydroxide. Okay, so now I need to figure out moles of hydrochloric acid. So I have two different chemicals here. Okay, and I know, okay, so how would I link them? What do I need to write?
An equation.
Good, an equation. Okay, so NaOH is an easy equation. Plus HCl gives me NaCl plus HOH, and it's balanced. So my sodium hydroxide is a 1-to-1 ratio with hydrochloric acid. So however much sodium hydroxide I have the same amount of hydrochloric acid. So therefore, there is 3.727 times 10 minus 3 moles of hydrochloric acid. Okay, so that's moles of hydrochloric acid, so moles of sodium hydroxide, moles of hydrochloric acid. And now I need to figure out, well, that's how many moles of HCl is left over. Now I need to figure out how many moles of HCl was used to react with the calcium hydroxide. So moles HCl used. Okay, I want that underline to be right. Okay. All right, so I do my total moles HCl minus mole HCl left gives me mole HCl used. Okay, so my total moles of hydrochloric acid, all of the hydrochloric acid that I poured in. Okay, so that was, so it's my total. 0.050 GM3 times 0.2500 GM3 These cancel. So I have 0.01250 mole HCl. Okay, so this is my total moles of hydrochloric acid. Didn't need to move that second question down. Okay, so let's subtract them. 216. Okay, so 0.01250 moles HCl minus 3.727 times 10 minus 3 moles HCl. So this is my total. This is how many moles of hydrochloric acid I've used. And that equals 8.773 times 10 minus 3 moles of HCl is used. Okay, so that as I have mole of HCl used. Now I know how many moles of HCl I've used, so how much calcium hydroxide did that react with? All right, so I have to link these two with the formula. So CaOH2 plus HCl gives me CaCl2. Okay, so there's a 2 there, there's a 2 there. So 2 moles. Okay, let's just do the math. HCl. Seven. Okay, so that's how many moles I have of calcium hydroxide. And I think I'm going to stop there because it is 219. Okay, so let me just go back to the screen and we're going to talk about some sort of strategies. Okay, so for questions like this, this is a beast of a question. You're probably not, like if you're anything like how I am, something like this, I wouldn't understand it the first time I see it. Okay, I would absolutely not understand it the first time I see it. I might get like I might pick up some patterns in a question like this, but I'd need to go over it step by step. And what you can try to do, what I always did, and it worked for me, was I would teach things to myself. So I'd kind of pretend that I am my own student and I would say, okay, step 1, this is what's going on, or this question, well, let's draw it out. Let's see what's going on here, right? So if you're sort of shaky on these really long questions, I think that that is totally normal. You would just need to go over it in more detail yourself. I'll give you a big hint. I put a question like this on your test. Okay, so it's broken down into steps. So it's not like, you know, I throw the whole chunk at you, but I do want you to know how to do questions like this. Okay, so I think it's worth your while to go over it. And then tomorrow honestly, I'm not gonna like redo the question, but I will start at the beginning and just go over the steps that we've done. So we can find the answer, okay? And when it comes time for your IA and you have to dissolve something in acid and back titrate it to figure stuff out, you'll have some nice worked questions to refer to. Okay, so I'm gonna sign off. Sorry again about the tutorial.